Hi everyone. Today
I
we are
said
going
good
to
morning.
start.
Good morning.
Good morning. Yeah. Today we are going to start with the collections. So uh, the collection, you can say that it can be defined to work with groups of objects. You have the collection interfaces. The following interfaces you have in your collections. Like you have this collection interface itself enables you to work with groups of objects, and when you define this collection framework, so you have several frameworks that I'm going to write now. So but this particular collection is at the top of the hierarchy of the collection interfaces. Now you have called the queue. It also extends the queue. It extends the queue to handle a double-ended queue. This has been added after Java 6. Okay, this DQ or queue. Now you have list. It extends the collections, extends this particular called collection, this particular collection, and to handle the sequence. That means when you in a list, this interface, when you add in this list like called A, when you add one, the elements 1, 3, 5, like 1, 3, 5, if you add here, this maintains the sequence, means the way it is added. If you print this particular list, you are going to print this in a particular sequence. Now you have navigation set. Navigation set or the DQ, this we will hardly use in this. This extends the sorted set. I will let you know what is this sorted set. Okay, to handle retrieval, as it is a navigation this, it extends the sorted set to handle the navigation, the retrieve, the retrieval of elements based on a closest searches. And you have queue. It also extends your collection to handle special type of space in which elements are removed only from the head. That means from only from one end, starting only from the starting point. Then you have the set. This also called extends collection to handle sets, which contains only unique elements. And sorted set, as the name says, extends set to handle sorted sets. Whenever you are doing a sorted set, then it will automatically sort your set. And if it is a set, remember, then whenever you are going to add any elements, this is going to be an unique elements. So let's do one by one. So let's go to the list interface method, or the list interface. See, whenever we are going to add any list interface, that means it is going to handle the sequence. Means let's do one of the programs. And remember, we are going to do with an iterator also, but first we will do with a for each loop. You must know what is means. I have already taught the for each loop, and the great means usage of this for each loop is inside this collection framework. So this collection framework, I'm going to do it here. Let's check a program with the list, or let's do collection framework. My package name, I'm going to write a program with the list, sorry, with only the list and the list interface. And now we will just make a object of a new array list. Let's do which implements the list interface. And remember, array list supports this. When you are going to do a program, remember, I'm going to write a program now, class called, say, array list. First array list demo. Remember, in arrays, when you were doing in arrays, just the arrays like a this, you were giving only one type of elements, either string or your integer. But remember, in array list, what you can do, you can give a string, you can give string, you can give somewhere, and then you check how this is being printed. Like I'm doing an array list, maybe say array list. This will contain only string values. So I'm giving a generic, making it a generic, making it a type safety. Okay, this is where is the mistake I have done. Again somewhere. Okay, I haven't made the object. Now you can see I need to extend this, import this java.util. Let me make it a star. I need to import inside this java.util. You have all your collection framework, all the collections that we are saying. So I've imported this. Now let us check. Okay, sorry. I've forgotten to create the public static void void main initial size. Now you check. See, array list. Remember, array list supports dynamic arrays that can grow when needed. Means you do not have to define the array list length from beforehand. So you can just do, suppose if I'm writing, see it is growing, al dot add. I'm adding the first element, say C. Then I'm adding again al dot add B. Al dot add. Suppose I'm doing as E. With with each of this dot add, this particular string, this particular array list is increasing with its um, with its size. Sorry, the size of this array list is increasing. If I do something called array list add f, see, the size is increasing. So we can say this array list, this implements your list interface, and and it supports dynamic array that grows when needed. Means you can just, without knowing the size of an array, you can just click on and just execute the, means just add the elements, and it will automatically, the size will automatically increase in your memory. So if I say something now, you check the size. If I run this program, see, first the size is 0, then whenever I'm adding the elements, it is automatically the size is being increased. You can also remove the elements from here. Suppose I'm removing this particular called f. Now you can check the size. It should show me 3. I'm not sure what it will show me. So let's check. See, this is the way that I can do. And suppose it's the, remember, always in your program, it's better you write in this way. So this is the list interface. You can check. This is the list interface. Okay, that contains your string, and you are just doing it as and you are making an interface, or making, and sorry, this list is an interface, and you are making an object of the array list. Remember, we cannot instantiate interface and then we can just create a new to form an object of an interface, but we can do that. We can just refer an interface in the memory and create an object of the particular class that it is implementing. So my array list is implementing this particular class. Array list is implementing my list interface. See, it's automatically implementing. So for the polymorphism, we can write the list al equal to new array list. So these all are my list or array list operator. and and sorry, not operator, means the type is of list and array list. And remember, can you tell me how do I just print these elements now? Anybody, without using the iterator? Hello?
Yes, sir.
Do you remember the for each loop?
Yeah.
Okay, so let's write this for int. Suppose it was a string, so I can write string as this and the list. Now let's check. This is a string type, and this al is a string. The you can see the list is a string. So I'm printing the strings. See, it is printing me C, D, E, and F. Now, suppose if it was a linked list. So the linked list class, or we can say, let's go with the linked list. These are the classes, these are the interfaces that we have done, and these are the classes, what we are doing now. These are the classes. Remember, now the linked list class, it extends, is called abstract sequential list. This is the abstract class. So it extends this and the interfaces it implements the list. I think this DQ and your queue interfaces. So we can say that it will be a sequential. This particular linked list will be a sequential as it extends the as it implements um, this list interface. So this is going to be my sequence. This is going to maintain my sequence as it is a DQ. So it is going to handle me a double queue, and as it is a queue, so it is extending me this type of list in which the elements are removed from only one end. So let's do a program with the linked list. Let's check a program. Suppose I'm doing a class called linked list. Remember, this is going to be a sequential. linked linked list. I'm doing this as something called LL new. I need to import the java.util. Let's say the type parameters. Let's check this. Oh, it is saying me to remove the it is not letting me to use this particular called. I cannot use the generic objects on the linked list. Let's check if I'm using it. See, it is giving me an error. So it is saying me to remove this particular this type of arguments. I will let you know why it is not letting me to use this particular linked list. That it is not particular letting me to use that particular generic values. I will let you know. Now, if I'm adding, this is also growing. Remember, this will also grow as a dynamic array list. Mhm. I'm making a mistake somewhere. Let me find out the mistake. This is an object. No. Okay. Okay. See the mistake where I was doing. Yeah, now you can check the mistake that I was doing. I have created the class name as linked list. So it was not letting me to create, I mean, I was creating an object. So it was not letting me to do generics. But I was thinking that the whole collection framework is you can make it as a type safety. So now let me check, add similar as your array list. Now let me do it as add ll dot add is b, suppose, then to more I'm giving it addition. and D. Yeah, I remember. Anybody, do you remember I had given a question in the thread? I'm coming to the linked list again. When can we use the run implementation and when we are going to extend my thread class? Anybody? Hello, class. Monica, Anusha, Sandeep, Tejeshwani.
Yes, sir.
Yeah, I had given a particular means I had asked you to go through when can you use a particular runnable interface, means when we are going to implement the runnable interface and when we are going to extend the thread class. If you haven't gone, please go through and let me know the answer tomorrow. Okay?
Okay.
Yeah. And you check. This is the linked list. So I'm adding at last one element called Z, and at first I'm adding one more element called LL add first is your A, or maybe something called F. This will be the first. Now let's print the original contents of this out. Original contents. Make it LL. Now let me do remove the elements from the array list. Suppose we are removing it. Remove the elements from linked, this particular linked list, not array list. It's going to be from the linked list. You can check. I'm removing in the same way. Remove, suppose B I'm removing. Now check. After deletion, check this too. Check. The original contents was this, then I'm removing B. See, now the content has come after removing this particular elements. Now if I want to remove the first and the last element, that A and Z, like we have added last, added first, then we can do it in similar fashion. LL dot remove, we have this particular called first, we also have called remove, this particular called last. Now if you can see another after deletion, see F and Z has been removed. So this is my linked list, and these two as we have done. Now we can go with the has set. Remember this has set or the set or the linked has set or tree set, whatever we are doing, we are going to do it here is uh, is one of the most important functionalities of this particular called Java world. So let's do with the has set class. Remember, this extends your abstract set and implements this particular called set. We are implementing this particular set. Now, what happens when you are doing any hash set? What is the difference between your list or your hash set? Remember, in hash set, you have a called hashing. There's a term called hashing, or you have a hash code. So when you just add, remember when once one adds any element, it gets an unique hash code. Means, remember, when you add something called suppose you are adding a to your list. So what happens? 1 2 3 4 5, maybe the memory reference, this is called the hash code. This will be linked with your a, and this 1 2 3 4 5 is going to be the key pair value. You can say this key and pair value. This is the key. A hash code is going to be your key, and this a is going to be your value. So whenever you define anything in a set, means whenever you are defining the hash set or implementing this set, if you adding any particular value to it, suppose like a, then an hash code in the memory is automatically defined for this particular value called a. So whenever um, this hash code, remember this hash code already it's been unique also, and and what I will say, it is also used, it is also, suppose it is also used as the index at which data associated with the key store. That is what I'm saying. Suppose a key or a hash code is defined automatically in the JVM called 1 2 3 4 5, and then it has your a, this particular value. Now when you are going to add any means when you are going to add any particular called b, then again it is going to be a hash code will be defined in a memory, suppose 1362, and this is going to be your b. But when you are going to add any a again, so automatically the key that is already present, it will come to it to 1 2 3 4 5, and this automatically will get added. Means it will not let you, because this already hash code is already present. So it will automatically check, okay, this particular a, it has this particular key 1 2 3 4 5, this is already present inside the set, so it will not let you to add this particular a. So let's see a program of your hash demo. Hash set demo, and this hash set demo may not be your sequential, it may not be. Let's check this. Let's check this hash demo. Public static void main and string args suppose has set string has set is new has set string. Let me import this, and now I'm going to add hs.add e hs dot add maybe a hs dot add c. These are, suppose I have added all these things. Now you check on more 3 4. Now let's this. I'm printing this has set. Let's check what it is doing. See, it is not sequential. You can see this is not my sequential. This is printing me in a sorted set. Remember, but this is not is your sorted set or something. Okay. Maybe it is printing me in this type of called in a sorted set. Remember, implements the set interface backed by hash table. Hash table means it has a hash map inside. That is means hashing means hash map. The key pair value. When we will go with the hash map, I will let you know. So it is automatically having a. Now let me and add one more element called with the same, that is I'm adding again this particular called add a. Suppose if I'm adding again called add a, let's check what it's going to be printing me. See, it is not printing me two a's but rather only one a. So this is not added. But if the same, if I use this in my array list, suppose def, again I'm going to add f in my array list, add f. So it should print me two f's. Let's check. Just wait a minute. I'm removing this f. Rather you do it b, d. See, my two d's are being printed. So the difference you can say between the array list and this. So in the hash map, you have called it is called hashing. Hashing means the key pair value is being generated there. Whenever I'm done A already here, a key has been assigned to it. Suppose it is 1, 2, 3, 4, 5. When I'm trying to add 1, 2, 3, 4, 5 again, means this particular key for A, it is not letting me to add. Instead, it has already been added. So it is ignoring this particular value. See. Now in the hash demo, if I'm loading again, you can check. This is printing me A, B, C, D, E, F. Two A's are not being printed here. So do you have any questions still here?
Excuse me, sir.
Yeah.
Can we print the array list directly? Like how you printed H's? Can we
Yeah,
print?
let's check. Let's check if we can print this all. So you can. Let's check. See, we are printing the array list.
Okay. Yes, sir. So,
Yeah. Yeah. Any question?
what's the difference, sir? Hash set has key value pairs, and linked list will be like one node will be connected to the other node, or how it will store in memory. And what about the array
No.
list?
Array list. See, array list is nothing. Sequence wise, it is going to store. Suppose you have the elements called A, B, C, D. Okay. These are the elements of your array list. Elements of your array list. So it is storing. Suppose you have it will sequentially the memory will be referred. Suppose you have, let me go to the print. Suppose this is your array list. What happens? It gets the size is increasing. This particular will increase with your this. And suppose you are it has the size called, let me do it again, a small one. Suppose it has now the array list is 0, the size is 0 when you haven't added anything, it is 0, and the memory is referred to as 1 2 3 4 5. It doesn't have anything, so the size is 0. Okay, now whenever you are increasing some array list, remember, whenever you are increasing the array list, the size of this particular array list is being increased like this. Suppose this is the same 1 2 3 4 5. Now if I am doing, suppose if it is A, suppose the size A, B, C. I'm very bad at drawing, so suppose it has here A, sequentially it is storing here B, C. Remember, whenever it is array list is here, now you can see that the it has the size as your particular called 3. The size is 3. This is storing as a sequential wise. But in a hash map, what it happens, whenever you are storing A, B, C, it is being stored in this way. Suppose you have a, it has a, suppose you can go here and you can check. It is saying me this particular line actually a hash map instance. It has a hash table. That means That means whenever you are storing ABC in a hash map, it is going to suppose hash code, a random hash code is being generated, and this is unique for each of the elements. Suppose a hash code is generated as 346, and your array, this is your key, and the value will be stored at A. Now, for B, again something called suppose 4567, then it is your B. Then it is called again, suppose 5, 6, 7, 8, then your C. This is going to be stored as your key pair value in your hash table. But remember, in array list, it is going to add sequentially. Whenever you are printing it, it is going to add your particular called sequential. And this hash table, whenever you are going to add any a again here, it is searching for 3, 4, 5, 6. This is already present. This particular called hash code is already present. Now you can just check, okay, it's just checking, okay, this particular hash code is already present, so let's not add it. It is not going to give you an error. See, when I'm adding a again, it is not going to give me an error, but this is not adding this particular a value here. So have you understood the difference? This array list is full sequential, but this hash table always implement the means the hash map on all hash set always implements this particular called hash table, which instance is an instance of an hash map and map.
Yeah, got it, sir.
Yeah, this is sequential, and this is suppose your key pair value. Now, if you want to add it as a preset, remember, I'm not sure that this is, though you are checking it, that it is printing me a sorted type of set. This is printing me a sorted hash set. Remember, this is my luck that it is printing me in a sorted way, but this may not be means in a sorted order. This may not be. If I had written something called a here, okay, let's check what would happen. It is again printing me a sorted hash set, but believe me, this hash set is not going to be my sorted way. This is my luck that it is printing me in a sorted way, but for that you have a particular called preset to do your particular called sorted values or something like this. If I had given here like called tree set, and again the this particular called tree set, and let me do it as a star, it's going to take me. So check, this is my sorted set, but believe me, this hash set is not your sorted one. And see, the elements are ordered using natural ordering or by comparator provides at the creation time, depending on which the constructor is used. So whenever you are doing this particular called tree set, whenever this you are adding the key pair value, the hash map is built in such a way that it takes your sorted in a descending order. This will take your sorted in a descending order, but hash set is not your sorted set. Tree set, the difference between the tree set and the tree set and hash set, that one is that tree set is sorted, but hash set is not. And remember, tree set also, this particular called tree set, it extends your abstract, same as this, extends abstract set, extends abstract set and implements this particular called navigation set. This interface it implements. It creates a tree as your storage and your ascending order set is being created. But if it is a hash set, though it is printing me your this uh, means in an ascending order. Believe me, it is not an ascending order that is being printed inside your array, inside your this hat set. Give me this again. It is okay. I've added here. This is printing me B C D F. Let me check if I can do this way. No, it is printing me. It is printing me your in a sorted set, but it is believed that means the hash set is not going to be your sorted set. This is not going to be your sorted set. I will let you know. I will let you know. I need to find if they have added any feature in the Java 8 for this particular called hash set, so that it is going to be your sorted set. But believe me, this hash set is not a sorted one, but the tree set is. And we will go to the prior. Can anyone tell me what is a queue? Anyone?
Mm,
I will go to the queue
it's
now.
like first in, first out.
Okay. Hmm. But still are not a satisfactory answer. What is the difference between a list and maybe a queue or something?
Mm,
We are doing it as a list or something. So is queue is my um, is it a what I will say a sorted one? Anybody?
I don't remember that. Yeah.
Okay, okay. General meaning is something called in a suppose English plain English language, it is a sequence of people or means people waiting their turn to be attended, right? A general term.
Yeah.
So it is the same thing. Aq, you have said that FIFO, first in, first out. That means whenever you are going to add, suppose a line of people already maintaining a queue. So the first person that has come, suppose you want to book and ticket for your any concert or any football match in a particular stadium. So you are maintaining the people who has come first is going to buy the ticket at first in a maintaining a queue. So if there are 10 people and they are maintaining a queue, the people who has come first will take the ticket at first. So you are correct that it is a first in, first out. That means whenever we are adding anything at the first, will also get deleted. If we are deleting, it is also we are going to delete it at the first, or the first element is going to be served at first and the last element is going to be served at last. So this is type of your queue. um, this queue, remember I told you what is a queue here. Now we have something called array dequeue or array queue, or we have also called priority queue. Same thing, it extends this abstract set and it implements your it implements my queue interface. This particular interface is doing my. So whenever I'm doing, suppose it's the same thing that we give the priority DQ here, then you do it here, means it has the functionality called like this, call it, suppose called priority queue, and then priority queue demo. Let me give this name. Now I'm going to add PQ, add, sorry, it has your 6 constructor inside it. PQ, I'm forgetting the priority DQ will be PQ. Let me do the constructor, call the constructor. Capacity. See, it has your, remember, I cannot define the priority queue here. The priority queue has your constructor like this. Priority, it has the 6 constructors made with itself. This is priority queue, again called int capacity, priority queue, int capacity, and then you have this particular called comparator. I'm going to tell you what is the difference between comparator and comparable. This comparator method, and then you have 3 more constructors called priority queue. You have the, you can do it with the collections, maybe suppose C. Then you can have priority queue, this class name itself, this priority queue, and PQ. These are the constructors we have, and one more that is called priority queue. Then you have the sorted set. Yes. This is your priority queue. Remember, the first constructor, this builds an empty queue. Remember the priorities queue. Whenever you are doing any means whenever you are doing, its capacity is always 11. The capacity of this priority queue, it's automatically generates as 11. The second constructor builds an queue that has specified the initial capacity. Means not a default, that is not default, but you can specify the capacity of this particular queue and do it here. And the third constructor builds a queue with the specified capacity and the comparator. Comparator means it is comparing the values, that is which is greater, loss or something. So there are two. Here you can give the capacity and also define the comparator. I will let you know what is a comparator and comparable, how it is being done here. Now, the fourth one you can see, means the last three you can see, it creates a queue that are initialized with elements that are collections passed in C. You can see. Rather, instead of doing it here, I could have done something called here. Let's check if I had done something in this way. What it is going to take me. Method called. Now, I'm going to do a particular called your write a program in your particular in this priority DQ, or let me do in this way something. Uh, sorry. It's better to do it with a set. It's better to do it instead of just overriding the methods. I was just trying to override the methods. I'm setting this set. That's it. In this particular called HS. Just letting me to sure why this I'm not able to set this particular value. Yeah. Okay, I will let you know tomorrow, because this particular set or set values priority queue, it has gone out of my mind. This priority queue I have hardly used ever in my program, so it has gone out of my mind. I'm going to let you know how we are going to set this particular called priority queue. This particular called priority queue. How to set this particular. Do you have any questions before your priority queue or the queue that we are going to teach? Any questions?
Yes, a small doubt. Um,
Yeah, tell me.
uh, like generally we use implementations of class for linked lists or any of the data structure, right?
Which one? I didn't get your
Um,
question.
for any of the data structures, we
Hmm.
use the class implementation, right, for implementing the data structures.
Class
So
implementation of the interface, like if you are using the list here, you can do it like this. I
okay,
showed you.
so this is the easy way for the implementation of data structures, right? Using generics.
Yeah, generics, using generics means it is going to be your type safety class, means it is going to be your type safety. So you have, see, I have defined the array list here. But if you are defining the linked list as your list interface and you are doing it new, remember these two, at last and at first, these are inclusive. These are only belongs to this particular class called linked list, not the list. So if I had made a something, it has its own method. See, if I am
Yeah.
giving it a list here, this at last and at first, these are defined inside the linked list. So we cannot make an object in this way for this particular called linked list and can use this particular at first, at last, or remove first and remove last. These are not present in your list interface.
Yes, sir. So instead of uh, like explicitly defining the add function or add first function or add last function, we can directly use this interfaces and directly use the default functions, right?
You can only use those, suppose if it has a list, okay, in your list you have this particular functions called
Yeah,
add
directly the
or
methods which are
remove or
implemented
something.
in that class, in that interface can be used.
Yeah, suppose I'm saying this array list does not have any particular method inside it. This array list is not going to have any method inside it. But for linked list, there are two methods, two or more methods, like at last, at first. But whenever you are doing a list, you are just referring to a list object. You cannot implement this, right? You cannot, because these are present inside linked list, not in the list.
Okay. Yeah.
Okay. So for array list, you can make this particular called interface, this list one, and as it is not providing any extra methods, so means inside this array list there are no extra methods that has been defined. So you can say, you can just implement this particular called list.
So if someone asks me to just implement an array or implement an linked list or something like queue, then I have to use all the functions, right? I can't use this one, right?
No, you have to use the functions. Only those are defined inside your list. You cannot, suppose linked list has two functions inside it. This class has two functions inside it, that is called array list or your, uh, I can show you, this is the class Java.
Yes, sir. I got
Uh,
it. I'm generally
okay,
asking, like, if someone asks me to implement a data structure in Java, like linked list
okay,
or queue,
okay, okay.
or a tree, then I have to define every function, right? I can't use this and just say it has add function and I can add the elements. I can remove, I can use this function and remove the elements. This is like ready-made use, right?
These are ready-made use, yeah. But the thing
So
is,
if someone asks me
you
to implement, I need to write each and every step, right, for the add function.
no. You cannot. It depends on your code, right?
Yes.
Suppose someone asks you to implement your linked list, and someone doesn't ask you to add the first and the last elements, so you can
Hmm.
do this. It doesn't matter, right?
Yes, sir.
If they ask you, remember, whenever they are asking you the linked list, that means they are believing that you are going to add this first, at last, or something. Because whenever I am doing it here, linked list here, remember it implements the list also, dq and q also. So it's sequence and your this in your dq like this, that q means the head, the first and the last. These elements, these objectives are always be given in your linked list. So if they are asking you to give an example of the linked list, believe me, they are morely, means they are thinking that you know this particular, that it has the methods called at last and at first. So this is the difference between your linked list and your array list. You do not have to define each and every functions. Like you cannot define it doesn't matter if you do not define this add or something. You don't have to, because you can check this array list. If I do it here, I've used only add and remove. It has lots and lots of methods inside it. You can see it has contents, it has add all, it has equals, it has last index of,
Okay, I got it.
it has
Yes, sir.
not, it has lots. See,
Yeah,
replace, right? I've
yeah,
only used only add and remove.
yeah.
So I didn't get your question actually. Maybe you're
Yes,
not
sir.
satisfied with my answer.
Actually, if someone asks me like without using the collection interface, implement a data structure, then I have to go the traditional way, right? Like,
Yeah, traditional way. See,
yes,
that means
that's
when
the
they are
question.
asking you, they are asking you to go with a traditional way. Means
Yeah,
these methods like add, okay, inside this particular called add, this is already are present in called java.util.this. Okay, that means inside this they have written a block of code for this particular method called add. So they, for your questions, like if you go to an interview, they are going to say you, okay, add me means define a data structure that will not implement or that will not import this particular called java.util.star, means
yeah,
java.util. That means they are not asking you to use the collection framework. That
yeah,
means, yeah, that means you need to go in your traditional way, that how you are going to add or you are going to do. Means how inside this, how this particular add method has been written, or this, they want you to know how this particular add or this particular list, these are already written. So believe me, inside this they have already written a code to add your element in the way, means the traditional way. They have given an array, maybe they are going to add one by one when you are adding it. Inside that already the code is been present, and they have all imported inside your called java.util dot in this particular called list. They have in this interface, they have already given this implementations and everything. You just need to, you are just implementing and using that on add function. Have you got that?
yes, I got it now. Yeah, yes, sir.
Yeah.
Yeah,
uh, because whenever you are going to a product company, maybe a product company, I'm not talking about service company, they will
yeah,
ask you to add in a means in your traditional way, because they want to check your knowledge. Because a layman can also see, okay, they can do that al dot add c. A layman can also check that, okay, I need to add c, that's why it is adding me in an array list. But how it is being added inside in at the back end, that has been given in the traditional way that
yeah.
you are talking about.
Okay, yes, sir. I got it.
Okay, okay, yeah.
Yeah.
And
Thank you.
I will, yeah, I will, if you want me, I will show you one or two programs that how they are being added in your traditional way. Do you
Uh,
want that to go through a bit, like in your map? When I will do it in my map or something in your ad, I will show you how these ads and these are done inside it and how they have written the code.
uh,
Okay, in future classes I'm going to do that.
okay, sir. Yeah,
Okay, then you will
yeah.
understand the traditional ways.
Okay, sir.
Okay, yeah. And any more questions do you have?
No, sir.
Okay, then I'm ending the question, means I'm leaving the meeting for today, and tomorrow I'm going to teach you the queue, because even I got confused, because I have never till date I have never used the dequeues and queues. These are the first. I'm not remembering how to use this. I had used last, I think, and 6 years ago during my training, that how this dequeue and this was being used. So I need to go through the classes again for only the queue part, and I will let you know how the queue part is being done. And this also the traditional way of doing ad. Because in one of the interviews when I changed my company, the same question was asked to me that without importing the java.util, you need to write how to add a program, to add elements and to remove the elements. And yes, I did those, and I will let you know how they are being done.
Okay, sir.
Okay. Yeah, yeah, yeah. Okay, bye.
Yes, sir. Thank you.